Welcome to part 4 of the webinar series, reviewing the Energy Code compliance for metal building systems as it relates to the Energy Code provisions. The next phase of the COMcheck trade-off review would be to provide specific case studies. This is a case study using a 2009 IECC example based off of what we learned before on how to enter in the metal building, roof, and wall information. Hopefully this will be of interest. We worked up a fire station building example, roughly 81 feet wide, 175 feet long. And the eave height, we've simply averaged it out. The inputs can be as comprehensive as you would like. So probably what you'll see will be more of a simplified version that for your particular project application could be expanded. We selected a couple sites in Colorado. So for this example, we selected Pueblo County in Colorado, which is climate zone 5B. Image of one of the drawings of the fire station. So the left-hand side of the screen would be where they house their vehicles, and the right-hand side is mainly for the office area. According to one of the resources for Colorado, the city of Rye is currently under the 2009 IECC, so we selected that. The base information for this example would be the 09 IECC, climate zone 5B, space conditioning for the all areas would be fully conditioned. I would enter in the following information into the building envelope portion of the software. I assumed the slab is unheated, 520 linear feet, where we have vertical rigid board 24 inches down for an R10. The exterior wall 20 to 24 feet eave height. I just simply averaged that out at 22 feet. So roughly 9,400 square feet of metal cladding. The roof area, a little over 1,400 square feet for a standing seam roof. And I entered in the glazing, 14 windows, metal framed. You're allowed up to a certain percentage of square footage window to wall ratio in the Energy Code. For this case, I only have 4%. Number of sectional doors, because it is a fire station, firehouse, and 5 man doors and a main entrance way. I based everything off of the minimum code compliant prescriptively out of the 2009 Energy Code for each of these opaque elements. And for the roof, R13 plus R13, the sag and bag type of system. Walls above grade, metal building, prescriptively, it calls out R13 plus R5.5 continuous insulation. We'll kind of go with that for the prescriptive example. And then I entered in the U factor and the solar heat gain information for the windows and the doors. I did not enter in any skylights. However, this would be a requirement, minimum requirement in the IECC in 90.1. So skylights have not been entered in. So this could be a red flag when you get to the checklist and the certificate compliance report. But the software does not really know that you're lacking skylights. Just as an FYI. So I entered in all this information into the building envelope tab. I selected the roof, exterior wall, windows, door, and floor. Now there's no basement. There's no skylights. So I entered in the building area type. For this case, I had all one type. I did not break things out by the building orientation. It was not a particular requirement in the 09 IECC, but I did modify this in one of the later case studies that we will review. If you enter in all this information for the doors and windows in the slab based off of the information shown on the earlier slides, to be minimum code compliant, it comes up with a passing grade of a 0.1%. Sometimes if you just enter the prescriptive information in based on the city and state location, you may not even pass. So there is some conservatism that has been built into the software. But the software is not used to show prescriptive compliance. However, just for my case study examples, I wanted to illustrate what has been traded off. So this was the best way I could think of to run through that. So let's zoom in on this information. I'm going to pull out these two boxed areas into the next slide. So you can see the text a little bit better. So for the first box, you have the assemblies entered in the second box, the gross area for each of these, whether I inserted cavity insulation or continuous insulation, the U factors that were manually inputted, which would be the white cells and not the grayed cells. And I added comments and descriptions. Now this is optional, but it's always helpful to refer back to see where the information was derived from. So I manually type that in. And so now let's, on the next few slides, see what we could trade off. So I'll focus in on the three areas, and I changed it up a little bit and trade off and try a filled cavity metal building roof, and let's try single layer metal building walls to see what happens. So I increased the insulation layers for the roof from an R13 plus R13 over the purlin system to a filled cavity system. So R19 plus R10 plus an R5 thermal block with a standing seam roof. So I manually inputted a 0.041 going with the other metal building roof option. I just put in a single layer R13, the wall, so a little bit less insulation for the wall. I did not go with the continuous insulation plus fiberglass for the wall. And so it looks like I broke down the walls in two areas. So I did the same for the both areas as it relates to the firehouse example. And what comes up, I pass. I'm 0.3% better than the code. So for the 09 IECC example, if you wanted to move away from the fiberglass plus continuous insulation option, maybe go with a little bit less insulation in the walls and a little bit more insulation in the roof. You could do that, and so this simply shows you what could be traded off. Or you could go with all continuous insulation for the walls whether you have rigid board for the walls, and put in no fiberglass in the walls. That could be an option, whether you want to reduce the level of insulation or increase it, and fiddle with the level of insulation in the roof. And you could put in less thermally efficient windows, doors, and skylights, or vice versa. So this will allow trade-offs in the building envelope. Also, another important thing to look into is increasing the level of insulation for the slab on grade. This could dramatically improve the passing grade of the envelope if you take a look at that. So let's try other roof and wall types. So for this, we'll try a different wall type and not change the roof. We'll go with the other mass wall option. It won't even be a metal building wall for this example. We'll go with the other U-factor option and you select mass wall. And the U-factor number that I'll manually enter in is a 0.115. And I derived this information based off of the 90.1 2016 table A3.1.1. This would assume an 8-inch block wall, partially grouted, with R5 continuous insulation, 4-inch brick, and a 1/2-inch airspace. So we'll use this for the part of the building that contains the vehicles. For the office area, we'll use a metal framed wall with brick facade. So the other metal building framed wall option, 6-inch studs, R19 fiberglass. Based on the Handbook of Fundamentals, we'll assume the 4-inch brick with a 1/2-inch airspace and the R values associated with that. Do some calculations, 1 over the U, and you get the U factor of a 0.099. So we'll keep the filled cavity roof options from our previous case study. So that was the R19 plus R10 filled cavity standing seam roof, but we'll move away from the R13 metal building wall and try to align with the drawing that we showed earlier, a black and white drawing that showed brick and block. And so for that particular building, there was block and brick for the portion that houses the vehicles, and for the office areas, it was metal studs with brick facade. So I picked the other mass wall, entered in the 0.115, and for the other steel framed wall, I plugged in 0.099, and I come up with a 0.4% better than code, which is great. This will review the case study for a 2015 IECC example. A previous recorded session, we reviewed the 09 IECC example. So let's get into this case study using the Department of Energy COMcheck software. We changed the location to the town of Boone, Colorado, 2015 IECC. Nothing else changed for the prescriptive information shown in the earlier case study for the building envelope. According to the web link provided at the bottom of the screen, the town of Boone, which is in climate zone 5B, follows the 2015 IECC. So let's take that same metal building, pick it up and move it to another part of the county that uses the more recent version of the IECC. This slide shows the differences between the 09 IECC case study in the prescriptive inputs, third column, and what was entered into the fourth column prescriptively just to meet the minimum base code. Everything dramatically increased as far as the level of insulation and thermally efficient windows and doors shown here in red, fourth column, and then we'll show an example for a trade-off in the fourth column. So the R13 plus R13 increased to a liner system. R19 plus R11, if you're going the R value method or the U factor method, is a 0.035 versus a 0.055. Walls above grade for the metal building walls increased from a 0.069 to a 0.052. Remember, the lower the U factor, the more thermally efficient the assembly. The IECC 2015 changed to the building orientation. So you may have different U factors or solar heat gain coefficient requirements based on which way the wall faces the sun. So when I go back to the project page and I switch it from the 09 to the 2015 IECC, a number of pop-ups occur or warning indicating that the software will not be code compliant from one version to the next. So for this case, it red flag a couple of the fenestration and door U factor inputs that does not meet the maximum area weighted average U factor. So we'll fix that in the coming slides. Other options pop up which we didn't have before is compliance options. So I picked high performance HVAC would be used. And I picked the air barrier permeability, going with the material assembly route for the air barrier options. The building type was red flagged. For now, this term was changed with the building type options, so I reselected the building type. This is basically the same example, but expanded further based on the building orientation, whether it's north, south, east, or west. And I broke things out a little bit further to separate the office area from the vehicle parking area for the fire station. So this is the orientation. Changed some of the information here to be code compliant minimally. And so it passes right on the money, 0%. So it's, as long as that thing is shaded green, we're good to go. I made notes in the right-hand column for further reference on where the information was derived from out of the 2015 IECC, or if it came from 90.1. So let's trade off some information here. So for all the walls, I want to increase it to the single layer in cavity R30 with the break strip tape of a 0.75 for the thermal block, or TB, but this is really a break strip tape. So for each of these, so the U factor is a 0.052. I moved away from the R13 fiberglass plus R13 continuous insulation for the metal building wall, and which ironically also is a 0.052. So it's not really a trade-off example. I'm just switching up insulation options. So technically this would just be using the U factor method And you would not even need to use the software if you're going that route, if you're just matching up the U factor and just changing the insulation system, the R value type shown in the tables, and going with a different system with the U factor that meets or exceeds what is being specified in the energy code. So obviously I still pass because I just kept the 0.052 and the 0% green, so that's good. Technically, to do a trade-off, you could increase the insulation level in the walls for those examples shown in the earlier slide and go with the new double layer cavity filled system. R25 plus R10, manually enter in the 0.047 in each of those areas within the software. Run your numbers and it'll say that you're now above code by 4.5%. So from there you could do trade-offs other areas, maybe put less insulation in the roof or less thermally efficient windows, doors, or skylights in order to get this number down closer to a 0%. But for now, we just leave it as this. So just to show you a simplified trade-off using the 2015 IECC. So once you're satisfied that you passed, you can take a look at the compliance certificate report. The project information would be shown in the upper portion of the certificate and a little bit more information about the building area. The certificate is a few pages long, so I tried to clip some information in these next few slides. So basically everything that was entered in is reproduced in the certificate. The last column shows the minimum code compliance, or what they call as the budget U factor, and what you are proposing. So this is the example where I use the R30 cavity filled insulation for the walls at the 0.052. So it aligns with the budget U factor with the R13 fiberglass plus R13 continuous insulation U factor. This certificate does not show the double layer cavity filled wall example. So it breaks it down from north to east to south to west. A little bit more information that it says it passes. And so for the last case study, it would actually say 4.5% better than the code if you didn't want to do anything different. The person that ran the COMcheck would need to sign this, their title and signature, and submit this along with any supporting reference documents needed. And there is an inspection checklist that's included. We won't spend a lot of time on this. I just clipped all the information that was included in the previous case study. So a lot of information is useful to the building inspector, and he would review this and make note if it complies or not, or if it's not observable in the field or not applicable. Notice on the bottom left-hand corner of the slide, the last row calls out the skylight area. Should be less than or equal to 3% of the gross area. Now, if there was a minimum area required for the skylight and it was not entered into the software, which you could tell by reviewing the earlier portion of the certificate, he would obviously say this does not comply, and the COMcheck software would need to be rerun and resubmitted. Some color coding is used, and this relates to how this could help out with the overall energy efficiency of the building. Depending on the color code means it would be highly important or would not affect the energy efficiency level. So the checklist runs through various things. So if you selected the building envelope with the material route, look at the second row. 0.004 would be the CFM per square foot. Looks like there's a typo there. Should be CFM, I think, per square foot. So just make sure that the building envelope area has been sealed. And more information pops up for the mechanical. So in closing, after reviewing the various case studies and reviewing the COMcheck software from the other portions of the pre-recorded session here, you need to make sure that COMcheck is permitted. Just note that ASHRAE 90.1 does include provisions, and the IECC is typically allowed because it is supported by the software. Just reconfirm that with the municipality. And you may notice it's easier to provide trade-offs regardless of the building type, even for metal buildings, if you use an older version of the standard or code. So less insulation is minimally code compliant, but you can always add more insulation in to the walls of the roof and do trade-offs. But when you get to the 2015 IECC or the 2013 90.1, you may notice it's harder to provide trade-offs. A little plug for our publications, particularly for the new second edition of the Energy Design Guide for Metal Building Systems. We encourage you to obtain a copy of this. It's a wealth of information. It's a couple hundred pages worth of information that outlines a lot of the information that has been reviewed in these webinar series, plus a lot more information that we have not covered. Electronic versions of the publications and hard copies are available. We recently published a guide for inspecting metal building systems, and we have our flagship manual, the Metal Building Systems Manual, Roofing Manual, and we have our Fire Resistance Design Guide publication. Thank you for listening in to this webinar or other webinars in the series. If you ever need to contact us for any project questions or code questions, feel free to contact us. You can find our contact information on our website at mbma.com or use the Contact Us form, and we'll respond back to you in a timely manner and give you a call to help you out with any questions you might have.